In this video, we're going to take a look at some factoring questions where you need to use a trig identity. So anytime I'm doing a question with trig, I would really like to see that all of the trig ratios are the same if I'm going to be factoring by decomposition. So in this case, I'm looking at 4 tan squared x plus 15 secant x minus 21. And I notice that the two trig ratios don't match. Now, if we were just common factoring, that might not be a big issue, but I need to have something that I can do. So usually I try to see if I can get them to be the same trig ratio. So one strategy is to write everything in terms of sine and cos, but then it gets really messy. So what I'm going to recommend doing is we're going to look at our identity sheet and see if we can find an identity that uses both tan and secant, so that either I can write my tan as a secant or I could write my secant as a tan. So up to this point, we have our three reciprocal functions, right? I do have something with a secant and something with a tan, but they are not in the same identity. We have our quotient identities, which do not have secant in them. And then we have our Pythagorean identities. So up to now, I told you that we could only go as far as sine squared plus cos squared equals 1. But in our last unit, we did actually, through the homework, end up proving the other two, which means we're now allowed to use those as well. So I see that there's an identity here that has both a tan and a secant. So I'm thinking we might be able to find a way to rearrange this so that we can write tan squared x using secant squared x. And I am just going to do a little rearranging off to the side. So the identity is that secant squared x equals 1 plus tan squared x. I have a tan squared x. So I'm going to do a little rearranging. We're going to take that 1 to the other side by subtracting 1. And it will give me that secant squared, oops, I missed the c, x minus 1 equals tan squared x. So we're going to take out the tan squared x and put in secant squared x minus 1. So that's going to give me 4 times secant squared x minus 1. And then plus 15 secant x minus 21. And that's our expression that we're trying to factor. So I would multiply the 4 into the bracket. The bracket doesn't have an exponent on the bracket, so I would absolutely multiply that in. That's going to give me 4 secant squared x, and then minus 4, plus 15 secant x, minus 21. I do have some like terms here. I can put the minus 4 and the minus 21 together, and that gives me 4 secant squared x, plus 15 secant x, and then minus 25. Okay, from here I notice that I have 3 terms, right? We've got something with a square, something without a square, and then just a number. So I should be able to use decomposition. If you would like to do variable replacement, that would probably be a good idea. So I think that's what I'm going to do. If you feel confident factoring with the secant, then that's great. If I want to do some variable replacement, I'm going to go over to the side here, and I'm just going to take out the secant, and I'm going to let that be a. So I'm going to let a be secant x, which means this would be 4a with a square, plus 15, and then a, minus 25. And then from here, we're just going to do some decomposition. We're going to look to see if we can find 2 terms that were the like terms that gave us 15a. So we're looking for 2 terms that add to 15. And then the clue is that they should multiply to the same thing as the first and last term, which is negative 100. Okay, so I want to try to think of things that multiply to 100 and then see if they add to 15. So if you have a multiplication grid or you know your multiplication facts, that's a good strategy. If you don't, then I normally would start with 1 and then divide this number by 1. I'm not worried about the negative right now. So 100 divided by 1 is 100. Can I make a 15 out of a 1 and a 100? No. I can make 101 or 99. All right, then I'm going to move up to 2. 100 divided by 2 is 50. Can I make a 15 out of a 2 and a 50? If I add them, I get 52. If I subtract them, I get 48. So that's a no. 3, 100 does not divide evenly by 3. I get a decimal, so we're going to skip that. I will go for 4. 100 divided by 4 is 25. If I add, I get 29. If I subtract, I get 21. Still not 15. It also divides by 5. 100 divided by 5 is 20. Now, I can add to 25, or I can subtract to get 15. So since it's a positive 15, the larger number would need to be positive, and then the smaller number would need to be the negative. And then you should always just check, do those actually multiply to negative 100? And the answer is yes, they do. So we're going to do negative 5 and positive 20. All right, so we're going to replace that 15. So I have 4a squared. I think I might put the 20 with the 4 and the 5 with the 25. Right, and they are a's because we are replacing that term that has an a. I'm going to group first term and last term. First two both divide by 4, and they both have an a. What do I multiply 4a by to get 4a squared? I need another a. What do I multiply 4a by to get 20a? That would be a 5. Sign always comes from the middle. And then these two both divide by 5. What would I multiply negative 5 by to get negative 5a? A. What would I multiply negative 5 by to get negative 25? That would be positive 5. These two brackets should always be the same, which they are. So this is going to be a plus 5 and then 4a minus 5. So our question didn't start with a's, so I need to put those back in. This is now going to be secant plus 5. So I have secant x and then plus 5. And then 4 times a, or 4 times secant x, and then minus 5. And it's now factored. All right, I'll see you in the next video.